Okay, now we're going to move on to our next type of heat problem, and it's called heat of solution. Heat of solution is the heat produced by a chemical reaction, or the heat required for a chemical reaction to occur. It's the heat that is released or absorbed when we dissolve something. So we looked at this way back in the beginning of the year when we did our copper 2 chloride lab, the green stuff that we put the foil in. And when I put that green stuff in and stirred it, it turned blue, first of all, but it also had a small change in temperature. And I had mentioned that we can identify chemicals based on their change in temperature that occurs when we add them to water. Well, now we're going to get to look at the calculations that go along with that. So heat is absorbed from the atmosphere or released into the atmosphere. There's two types of reactions. There's endothermic and exothermic, and this is where positive and negative values come into play. So I've always had you do your heat calculations as positive. This is going to be the one time that we're going to add in some negatives to get the proper answer. So it requires heat energy from the environment to get the reaction to run. Heat is transferred from the environment, from the surroundings, to the reaction, and therefore it's a positive value. Exothermic reactions produce heat. So in an endothermic reaction, when we put a chemical into water in our calorimeter, it's going to go down in temperature. You might want to add that to your notes. In an exothermic reaction, when we add the chemical to the calorimeter, it's going to increase in temperature. So heat is transferred from the reaction to the environment being the water that we're measuring the temperature of. It's a negative number. And so here, where all of our answers so far have been positive, we're going to have to go back in and make our exothermic reactions negative. Overall, I think this is the easiest thing to do when you see this kind of problem. So let's try one. What is the enthalpy of solution in kilojoules per mole if 6.34 grams of KOH, potassium hydroxide, is dissolved in 98.4 grams of water? The temperature of the water changes from 24.5 to 22.0. Is this exothermic or endothermic? And if we look right at it, our temperature is going from 24 to 22. It's going down. Endo has the beginning part of down in it. So if it's going down, this is going to be an endothermic reaction, and therefore our answer is going to be positive. If our temperature had gone up, it would have been exothermic, and we would have gone ahead and put in a negative. So the first thing I need to do is I need to figure out the heat. So to do a heat problem, Q equals mc delta T. And I'm looking at the heat that the water has absorbed from this reaction. So the important thing is that I'm measuring this for water. So I need to use the mass of the water, 98.4 grams. I need to use the specific heat capacity of water, the constant 4.184 joules per gram degrees Celsius. And I need to use the change in temperature, 24.5 degrees Celsius minus 22.0 degrees Celsius. Now we have to go ahead and calculate that. So you need to subtract the 24.5 and the 22, multiply it by 4.184, and then multiply it by 98.4. I end up with 1,029, and I'm not going to worry about significant figures until my final answer. So don't go crazy with the numbers after the decimal, but here I have 4 significant figures, and even if you wanted to make this 0.3, we're not going to worry about it until we get to the end, and that's joules. Okay? My answer is supposed to be in kilojoules per mole. So I need to take my joules and I need to convert it to kilojoules. So to do that, I can add it right onto here. 1 kilojoule is equal to 1,000 joules. Divide it by 1,000, and I'm going to get 1.029 kilojoules. Still 4 significant figures. It wants it in kilojoules per mole of chemical, so we want to see how many moles of chemical we used. Well, I used grams, okay, so I need to figure out my moles of chemical. So my next part of the problem is to take 6.34 grams of KOH, and I'm going to convert it to moles. So 1 mole of KOH, and then I have to do the gram formula weight. So potassium is 39.1, oxygen is 16, and hydrogen is 1.01. That gives me 56.11 grams. I'm going to go ahead and take my 6.34 and divide it by the 56.11, and I end up with 0.113 moles. My enthalpy of solution, delta H of solution, is what I'm looking for. So delta H of solution needs to be in kilojoules per mole. Well, the number of kilojoules that I used was 1.029. The number of moles that I used was 0.113 moles. So now I just need to divide those numbers, 1.029 divided by 0.113, and I end up with 9.12, and now I'm down to my three significant figures, kilojoules per mole for my heat of solution. We did decide already that my temperature went down, so it is endothermic. And for all heat of solution problems, I like us to go back in and actually put the positive in. So if it's a heat of solution problem, know that you're going to go ahead and put in a positive or put in a negative. Even though it seems redundant because 9.12 is positive, that's just the schematic that's used. So when you see heats of solution listed in tables, they label them as positive or negative, even though we usually assume. So I would like you to do the same. Heat of solution problems, you're going to go ahead and make sure you add in a positive or a negative, depending on whether the temperature went up or down. There's one last little thing that I want to show you, and that is boiling point. Does water always boil at 100 degrees Celsius? And I will do a demo sometime before our test regarding this. No. Boiling point depends on the atmospheric pressure. Boiling point is the temperature at which the vapor pressure of the liquid is the same as the atmospheric pressure. And so that's why up on a mountain, the boiling point of substances is lower, because the atmospheric pressure is lower higher up on a mountain. I can do a demonstration of this in class that will help illustrate this, but I wanted to put this, I know it's sort of unrelated, little slide in here to make sure that I mentioned it because it does deal with boiling point, and that's a significant part of this unit.